Hello. Today I want to talk about basic probability. That is your chapter 4 in the book. So the outline of what we're going to do today is I'll first of all introduce the basic concepts of probability, basic concept, basic definitions. Then I want to give an example of two independent events and two dependent events. And throughout the whole lecture, I want to show you how they're different. I want to see how marginal probability is different for those events, how the conditional probabilities is different for those events. And you'll see that it is a lot easier to work with events that are independent. It's much easier. And finally, the last thing we're going to do is we're going to look at Bayes' rule. And I will explain what it is when we get to it. It helps us to calculate probability and conditional probability, but I'll explain it when we get there. So first of all, let's start with the basic definitions. So first one is an event. So what is an event? Event is a possible outcome. So let me give you an example. Let's say we have a coin toss. With a coin toss, we can get either heads or we can get tails. So flipping a coin and getting heads, that's one event. That's an event. If flipped a coin and I got heads, that's an event. I got tails, that's another event. So that's what an event is. It is an outcome. We got two possible outcomes, heads or tails. We got two possible events. So another definition is simple event. Simple event. So how is simple event different from an event? So to illustrate this, I want to use a different example. Instead of flipping a coin, I want to use an example of rolling a die. So let's say roll a die. When we roll a die, we get 6 possible outcomes. We get 1, 2, 3, 4, 5, or 6. Each one of those 1, 2, 3, 4, and 5, and 6, those are simple events. Simple event has a single characteristic. Just one thing happens. It's either 1, 2, or 3. That's a simple event. An event, it can be different. An event, we can say we're only interested in getting odd versus even outcomes. So we can define an event as event 1 can be getting 1, 3, or 5. Getting an odd number. That's an event. A different event would be getting positive numbers. So that's a different event. So even though there are 6 possible simple events, there are really only 2 events. We can define event to be whatever we want to. With a simple event, we're just restricted to what it is, depending on how many outcomes are there. But an event we can define. So that's the difference between simple event and an event. A joint event. A joint event has to be at least 2 events. So another definition is a joint event. We need more than, it's a combination of at least 2 events. So for example, that can be tossing a coin twice and getting 2 heads in a row. That's a joint event. That's the first event was heads and the second event was heads. Combination of those 2 events is a joint event, getting 2 heads in a row. First event, heads. And tails, we get heads. Second event, we get heads again. So that's joint event. Another definition is complement. Complement. So what is a complement? Let's say, like, we're talking about events. We can define event to be whatever we want it to be. Let's say I define my event. I'm gonna roll a die, and if I get 5 or 6, then event A has happened. That's how I defined event A, 5 or 6. So this is my event A. Let's call it event A. A complement is anything else besides event A. So if you get 1, 2, 3, 4, or 5, that's a complement to event A, and it's denoted by A prime. So that's a complement. My event is A, get 5 or 6, anything else is A prime, a complement to A. Of course, always A plus A prime is always to 100%. I'm 100% certain that I will get either A or a prime, a complement or an event or a complement to that. That's 100% certain. Equals 1, 100%. So that's a complement. Now the last definition I want to talk about is sample space. A sample space is all possible events. So sample space. Sample space. This is our sample space. If we're rolling a die, this is 1, 2, 3, 4, 5, and 6. That's our sample space. If we're tossing a coin, then heads or tails, that's our sample space. This is all possible outcomes. So this is sample space. So now I want to get to the part with independent events and dependent events. So we just covered basic definitions. Now I want to talk about dependent and independent events. And I want to start with independent events. Let me erase this really quick. So let's start with 2 independent events. It's a coin toss. One event is a coin toss, and we can get either heads or tails. Say another independent event, we can roll a die. It's obviously if I flip a coin, I get either heads or tails, and then I roll a die. They're completely independent. Whatever I get on a coin toss has no effect on what I'm going to get on a die. It doesn't matter. So at this point, probability of getting heads is 50% because there are two possible outcomes. It's either heads or tails, and they're equally likely. So we get a 50% chance, or 0.5 of getting heads or tails. Now I want to look at both of those events, but they're independent. So if I get heads and then I roll a die, then the probability of getting 1, 2, 3, 4, or 5, or 6, they're the same. They're equal. So probability of getting is 1 over 6. Probability of getting any of those numbers on a die, they're equal. There's 6 possible outcomes. Each of those are equally likely, so possibility of getting 1 or 3 is 1/6. If I get a head, and the same thing if I get a tail, because it doesn't matter. Those events are independent. If I get whatever I get here, they're still equally likely. It's 1/6. Get whatever. So it doesn't matter. It doesn't matter whether I'm here or whether I'm here. The probability of getting, let's say, a 3 is exactly the same whether I got heads or I got tails on the coin toss, because those events are independent. Independent events are. Okay, let me talk about dependent events. How dependent events are different. Let's say let's say there are two regions in the world: Western Europe and South America, and that's it. That's the whole world, just Western Europe and South America. And then let's say they're of equal size. The population of those two regions is exactly the same. So we got Western Europe and we got South America. If we want to choose a random person, just randomly, they're equally likely to be from Western Europe or South America. Now let's say that the Copa America that's going on, it's like a World Cup or Euro Cup of South America. Europeans like soccer, so they're gonna watch it. They're even gonna watch it, even the South American Cup. But not all of them are gonna watch that because their favorite teams aren't playing, their countries aren't playing. So let's say the probability that a person, a Western European, somebody who lives in Western Europe, is following Copa America is 40%. Let's say it's 0.4. So that they're following so the probability that the Western European is following Copa America is 40%. The probability that they are not following is 60%. I'm just making up those numbers to illustrate the point, but let's just stick to them. Now for South American, they also like soccer. They maybe like it even more. Plus, their countries are playing. Argentinians are going to follow. Argentina is playing. Brazilians are going to follow because Brazil is playing. So since their countries, the home countries are playing, more people in that region are going to follow it. So let's say 90% of South Americans will follow Copa America. 90%. And 10% will not follow. I'm just writing it as decimals, but that's the same thing. So now those events are not independent, because it does matter. If we randomly picked a Western European, they're less likely to follow Copa America than if we would have picked a South American. So those two events are not independent. They are dependent. The probability of whether a person is following Copa America or not following depends on which region they're from. Where here, it doesn't matter whether we get heads or tails on the first toss. The probability of getting whatever we want to get, a 5 on the die, is exactly the same in both of those cases. So those two events are independent. Those two events are dependent. The probability of somebody following Copa America depends on the region where they're from. Those are the concepts of probability of dependent events and independent events.